Hello guys, welcome back. Today we are going to discuss end semester question paper solutions of numerical analysis and design assigned by Dr. Shaligram Prajapat. So let's begin. First question is to find the roots of the polynomial x square minus x minus 1 through the fixed point iteration method. Also to make a table for a various possible equation and show their nature, whether they are convergent or divergent in nature. So first we assume that let f of x square minus x minus 1 and f of 1 be negative and f of 2 be positive. Hence root is between point x equal to 1 and x equal to 2. So we can take that x naught equal to 1.5 as a median value. We take this median value by 1 plus 2 divide by 2 because there are two values, so we get 3 upon 2, that is 1.5. So here are the following equation g of x that can be made through f of x, that is root x plus 1, 1 upon x minus 1, 1 upon x plus 1 and x square minus 1. When we take first derivative we get 1 upon this value we get, and then the g of 1 is less than 1, g of 2 is also less than 1, g of for this equation it is greater than 1, and for here it is greater than or equal to 1. Here it is greater than or equal to 1, or here less than 1, greater than 1 and greater than 1. For the selection of correct g of x, we should g dash x should be less than 1. So here this condition is true. And if multiple value of g of x are less than 1, then choose the least one. Here only this value of g of 1 is less than 1, so this is the correct g of x. So the table of convergence here would be this equation is convergent and all the other equations are divergent. Hence the root is 1.618001. So let's move on to question number 2. Find the solution of system of given equation using the iterative method. We are given here three equations: 20a plus b minus 2c 17, 3a plus 20b minus c equal to minus 18, and 2a minus 3b plus 20c equal to 17. Now what we do is we find the value of a, b, c in the respective equation. Here a is 17 minus b plus 2c whole upon 20, b is minus 18 minus 3a plus c whole upon 20, and c is 17 minus 2a plus 3b upon 2a. Let a0 equal to 0, b0 equal to 0 and c0 is equal to 0. Now we get the value of a is equal to 17 minus 0 plus 0 upon 20, that is 17 upon 20. Here b is minus 18 upon 20 and c is 17 upon 20. We get a1 equal to 0.85, b1 is 0.9 and c1 is 0.85. Then again we put the value of this in these equation, where a is 17 minus we get this, and we get the value of a2 as 0.98, b2 as minus 0.985 and c2 as 0.63. Then we again do the same thing and we find the value of a3, b3, c3. We do the same thing and find the value of a4, b4, c4, and we'll follow this step till we get repeated approximate values. Now question number 3 is list out 4 disadvantages of Gauss elimination and 3 advantages of iterative methods over the elimination method. The iterative method is superior to the elimination method due to: first reason is computational effort is approximately 2n square arithmetic operation per iteration. and if convergence is achieved in less than n iteration, it is significantly superior compared to the elimination method. Second is the iterative method is small rounding error. It is small rounding error. The rounding error being a 1 committed in the last iteration. Thus, for ill-conditioned system, an iterative method is a word choice. In Gauss-Seidel method, we get xi equal to the newly calculated value of the iterate stored in temp. Disadvantages are as follows. The computational effort is approximately 2n3 upon 3 arithmetic operation in each elimination step. The amount of bookkeeping necessary is considerable. Rounding error may become quite large, particularly for ill-conditioned equation. Any special structure in the matrix of coefficient is difficult to preserve during elimination. Then question 4 is to write an algorithm for Lagrange's inverse interpolation. We have done this. It is very easy. First is to read the number of inputs n. Then we read the value of x. We do a loop that is for I equal to 0 to I equal to n minus 1. Read x comma y, and then we set sum to 0. Last is to set for I is equal to 0 and for 2 I equal to n minus 1. Set product is equal to 1. Inside it is another loop that is for j equal to 0 to j equal to n minus 1. Now, if I is equal to j, then product is equal to product into y minus yi upon yi minus yj, and sum is equal to sum plus xi into product, and then we print this sum. This is the algorithm for Lagrange inverse interpolation. Question 5th is to evaluate from the limit 0 to 1, 1 upon 1 plus x square, the 3-point Gauss quadrature formula for the given abscissa and weight. Weight is, here we are given T1, T2, T3 and W1, W2, W3. Now, let A is equal to 0 and B is equal to 1. We set the limit. Then we do x is equal to B minus A upon 2 into T plus B plus A upon 2. Putting the values of A and B, we get x is equal to 1 plus T upon 2 and dx is equal to dt upon 2. Substituting the value of x and dx in f of x, then we get f of t is equal to minus 1 to 1, 2 upon y plus 1 plus t whole square dt. We put the values over here and then we get 2 dt upon 4 plus 1 plus t whole square type equation here. We say this value is 0.78527. Write an algorithm for Weedle rule for the 6 points. Okay, first is read start, then read end. Then h is equal to n minus start upon 6. We get a loop here that is for I equal to 0 to I equal to 6, read y of I. S is equal to 0.3 h into y0 plus 5 plus y2 plus 6y3 plus y4 plus 5y5 plus y6, and then we print s. This is the algorithm for Weedle rule. Then algorithm for Runge-Kutta fourth order method. First we define f of x comma y. Then we read starting, ending and splits. H is equal to ending starting upon splits, while starting is less than equal to ending. These are the 4 values of k, that is k1 is equal to h into f of x comma y, k2 is equal to h into f of x plus h upon 2, y plus k1 upon 2, k3 equal to h into f of x plus h by 2, y plus k2 by 2, k4 is h into f of x plus h comma y plus k3, x is equal to x plus h starting plus h, y is then this formula states that y is equal to k1 plus 2k2 plus 2k3 plus k4 upon 6. This gives the formula of Ranjit-Kotta fourth order method. Print x comma y. So this was the algorithm of Ranjit-Kotta fourth order method. Now this is another question that says apply predictor corrected method to solve dy by dx equal to minus xy, y of 0 equal to 1 in steps of 0.1 up to y 0.2. Here we use this formula that says y to the power p n plus 2 is equal to yn plus 2hf xn plus 1 comma yn plus 1. That also y to the power c n plus 1 is equal to y of n plus h upon 2 f of xn comma yn plus f of xn plus 1 comma yn plus 1. So by Hume's method, k1 is equal to f of xi comma yi, k2 is equal to f of xi plus h by 2 comma yi plus k1 h by 2. Here k is equal to k1 plus k2 upon 2 and yi plus 1 equal to yi plus kh. Hence, y of 0.1 equal to 0.9975. These were the question of NSEM.